In this video, I would like to introduce the idea of an inverse function and look at a few examples. So let's say that we have a one-to-one function, f of x, that matches x values in a domain A with y values in a range B. That's what a function does, right? It's a relation between x and y values. And because this function is one-to-one, the relationship is unique. Every x value is matched with only one y value and vice versa. Then we can describe the inverse function of f as the function that does the opposite action. It takes values from a domain B and matches them with values in a range A such that f inverse of y equals x. We write the function that does this action as f inverse, which is how I read this mathematical symbol. This is not f to the power of -1. It's not 1 over f. This is our notation for an inverse function. Essentially, an inverse function maps y values back to x values. It does the opposite of the original function. And so we have the statement that f inverse of f of x is going to equal x, and f of f inverse of x is also going to equal x. A function and its inverse simply undo each other in their action. Let's look at a couple of specific examples. So first I have a table of values. These are just some x and y values that are matched on a function. So 1 matches with 1, 2 matches with 4, 3 matches with 9, and so on. If I were going to describe the domain and range of this function, I would simply say the domain is the points 1, 2, and 3, and the range is the numbers 1, 4, and 9. Now let's think about what an inverse function would accomplish here. An inverse function would take a value of x of 1 and match it to 1. It's the reverse action of what this function accomplishes. It would take an input of 4 and match it with 2, and it would take an input of 9 and match it with 3. So 1 goes to 1, 4 goes to 2, 9 goes to 3. This function, if we describe its domain and range, will have a domain of 1, 4, and 9, and a range of 1, 2, and 3. So notice that the domain and the range are switched for the function and its inverse. The domain of the function is the range of the inverse function. The range of the original function is the domain of the inverse function. Here's a second example written in equation form. We have a function x plus 6, and we have an inverse function defined as x minus 6. Let's convince ourselves that these are actually inverses of each other by looking at a couple of points. So let's say you have f of 0. f of 0 equals 6. We can observe that simply by plugging it in to the original function. Then it should be the case that f inverse matches this x and y value in the opposite direction. So f inverse of 6 should equal 0. And indeed, it does if we plug the input value 6 into the inverse function. In a similar way, we can see that f of 1 equals 7. Then it should be true that f inverse of 7 equals 1. And we can verify this with the equations that we are given. So these functions are inverses of each other because no matter what x and y value you choose, this relationship will work out the same. The input of one function becomes the output of the other, and vice versa. These functions have a domain and range of all real numbers. So it is true that the domain and the range get switched for a function and its inverse. However, here, because we are working with a linear function, its inverse is also linear, and there is no real change between the domain and range because it's all real numbers. There is one caution that I'd like to make here, and that is only one-to-one functions have inverses. If a function is not one-to-one, we may need to restrict its domain before we can talk about finding its inverse function. I want to show you why that is the case by looking at the absolute value function. So consider the absolute value of x. If you have an x value of 1, you have an output value of 1. X value of 0 gives an output of 0. X value of -1 gives an output of 1, and so on. Now consider what the inverse function is supposed to do. The inverse function is supposed to switch x and y values. So I should have the point 1, 1, 0, 0, and then from this last column, or row, 1, -1. But if we stop and think about it, this is not even a function, because now I have an input value of 1 that is matching to two different output values. Here 1 matches to 1, and here 1 matches to -1. This does not fit our definition of a function in the first place, so it cannot be an inverse function. We can get around this problem by restricting a domain. We'll look at this in more detail in a later video, but I want to say for now, imagine we take the same example and we simply say that we're only going to consider non-negative numbers. So f of x equals absolute value of x, but with this extra restriction that x is greater than or equal to 0. Then if we make a table of values, we will have 0, 0, 1, 1, 2, 2, and so on. And if we reverse these values, we will have a function, because the original function is now 1-to-1. Every x value matches to only one y value. And the same will be true with the inverse. It will be 0, 0, 1, 1, 2, 2, and so on. In fact, this function is its own inverse. It's not a very interesting function when we restrict the domain. We'll see more of that in a later video, and we'll also work with finding inverse functions and verifying that two functions are inverses of each